All right, hello physics students. Here is your concept development practice page 5.2. And this first page is asking us to use the parallelogram rule to carefully construct the resultants for the 8 pairs of vectors. So the parallelogram rule was that idea that you draw another set of horizontal and vertical lines, and when you are at your spot where your tails of your vectors meet, you get the resultant. So to do this first one, we want to take this and draw parallel. And then to draw parallel to this. And kind of where we intersect, that's the end of our resultant. So we go from the corner to the corner, and that's our resultant. Okay, so we're going to do that for all of these. So you can kind of do those at your own pace. Okay, I'm going to kind of do them right now for you, and you can kind of check to see that yours are sort of looking the same way. So again, I'm drawing parallel lines to both my vertical and horizontal components. And then from where my two meet to where my kind of opposite corner here, where my two parallel ones I've drawn intersect, that's my resultant. Again, doesn't really matter what order you do it in. So this time, notice my resultant is pointing a different direction. And again, this one also is going to kind of point up and to the left. Now, the second row, we kind of get things that aren't so square, right? I still do the same thing. So here I am, I'm going to work parallel. Okay. And here's this one. I'm going to work parallel. And then my resultant is still going to go from where the ends of my two vectors meet to kind of where my new two vectors that I've kind of drawn parallels for meet. Okay, so there's my resultant. So for this one, right, it's like this. So over here, here's that parallel line to that one. Okay, and then this one, it's just going to kind of go up. So from the end, and then again from where my two meet to where my other two meet, there is my resultant. So this time, right, I'm like this. So I'm going to come over here and be like that. And then this, coming down. And then my resultant this time would be kind of like down and to the left. Okay, and then this one, right, parallel. So there we go. And then parallel to this. And then again, from where my two meet to where the other two meet, which is kind of pretty much a straight line, right? Directly to the right on that one. Okay, so there are those. Hopefully you ended up with something similar. Now it's asking me to carefully construct the vertical. Remember, vertical means up and down, and horizontal, left and right, components of the 8 vectors. So here I have my resultant, and it wants me to get the vertical and the horizontal components of it. So basically I'm going to do it the same way, right? I'm going to go to the tip of this, okay, and kind of go straight back, straight down, and then here is my vertical component, and here is my horizontal component. Okay. So basically I'm doing the parallelogram rule again, but I'm kind of reversing it. So from my tip down to the lines they've given me for my horizontal and vertical. And then here's my vertical component of this one. And here is my horizontal component of this one. Okay, so this next one, so here is my horizontal component for this one, and here is my vertical component for this one. So on this one, right, they didn't give me kind of that horizontal line, but it would kind of be back here. So if I kind of just draw that in lightly, right? So I'm going to go from here back to that line, and then from here down to my horizontal line. Okay, and so here is my vertical component, and here is my horizontal component. Okay. This next one, again, here is my to figure out the one part of this, and then again I kind of need my up and down, my vertical line here. And then I have this. Great. And again, remember this is going from where my tails are going to be at the end, the start of my vector, and the start of my vector. So there's my horizontal and vertical components. So here, okay, and kind of need to know where my vertical is so I can figure out my horizontal. Great, so here's the vertical component of this one. And here is the horizontal component of this one. This one here, right, I need two parallel vertical lines. I have a one horizontal, I need another parallel horizontal line. Okay, and then because this is downward, here is my vertical component, and here is my horizontal component. And then this last one, they didn't give me kind of any lines for reference, right? But I still need them to be kind of vertical. So vertical, there's my verticals. Here's my horizontal. Here's my other horizontal. And again, this is going to be where my vectors are going to start. And this one's going to go down. So there's my vertical component. And again, I have to start back here, and here's my horizontal component. So there are the components of that vector. So now we're going to use this idea to look at this tossed ball. Okay, so we're going to use some of those same things that we were just doing on this tossed ball. A ball tossed upward has initial velocity components of 30 meters per second vertical and 5 meters per second horizontal. So we see that here, right? 30 meters per second vertical, 5 meters per second horizontal. The position of the ball is shown at 1 second intervals. So each picture here, that's a time of 1 second. Okay, so realistically, if I want to look at this, right, I have time equals 0 seconds, time equals 1 second, time equals 2 seconds, time equals 3 seconds, here's my time equals 4 seconds, here's my time equals 5 seconds, and here's my time equals 6 seconds. Okay? Air resistance is negligible and G equals 10 meters per second squared. Fill in the boxes, writing in the values of the velocity components ascending and your calculated resultant velocities descending. So, notice here, because it's horizontal and the horizontal portion of this doesn't change everywhere, okay, that's going to be 5 meters. So this is going to be 5 meters, this is going to be 5 meters, and this is going to be 5 meters. Okay? Horizontal component doesn't change, it stays constant. Now, what happens to the vertical? Well, we know that we have gravity, right? The acceleration due to gravity acting downward at 10 meters per second squared. So remember what that means is in a time of 1 second, it's going to decrease the speed by 10 meters per second. So it's 20 here. Up here it's going to be, it's 30 here. It's going to be 20 meters per second here. Here's another second, so now it's 10 meters per second. Notice here we have kind of our upward is 0 meters per second, but our horizontal would be 5 meters, right? Because our horizontal stays the same every time. All right, now it's 0 meters per second vertically up here, but now gravity is accelerating it. So it's going to increase its speed by 10 meters per second. So this is going to be 10 meters per second downward. Here it's going to be 20 meters per second downward. And here it's going to be 30 meters per second downward. Okay? Hopefully you're okay with that so far. So that's the first part of this. Okay? Now we want to calculate the resultant velocities. Right? We want to figure out what these resultants are. And they remind us that we're talking about triangles here, right? If we take a look back at one of these, right, if I know that this is 5 meters per second, and this is 10 meters per second, right, that's that. I have a triangle here. This is also 5 meters per second. This is also 10 meters per second. And if this is side A, leg A of my triangle, and this is leg B, to figure out this resultant C, I can use the Pythagorean theorem. A squared plus B squared equals C squared. To figure out C, I'm going to do the square root of A squared plus B squared. Okay? So that's when it looks like this. Now notice, it's not really a whole lot different than what's happening here, right? It's pretty much that same thing, but pointed downward instead of upward. It's going to work the same way. So notice here, the two sides, right? If I draw my parallelogram, right, this horizontal component is 5 meters per second. Sorry, it should all be per second because it's a speed. Okay. And this vertical component is 10 meters. So to figure out this resultant, I'm going to do C, which they kind of write it as a V. And I kind of like this, right? This is saying my velocity here is equal to my velocity in the x direction, my horizontal, squared, plus my velocity in my y direction squared, and then I have to take the square root of it. So, for this one here, my x direction is 5, and I have to square it. My y direction is 10, I have to square it, and then I need to take the square root of that. And let's just use one decimal, so I get 11.2 meters per second. So this next one here, right? One side is 5. The other side is 20. Then I take the square root of that answer, and I get 20.6 meters per second. This last one side is 5. I have to square it. The other side is 30. I have to square it. And then I'm going to take the square root of that answer, and I get 30.4 meters per second. Okay, so the resultant velocity here, okay, is 30.4 meters per second. So that is how you do that. Have a great day. I'll talk to you tomorrow.